Welcome to today's class. I'm glad to have you there. I want us to look at the equations of a traveling wave. In most external exams, O-level and A-level, students get challenged by questions coming from equations of a traveling wave. But today, I want us to look at it in a very simple way. So, we say that the equations of a plane progressive wave is given, generally it is written as y is equal to a sine kx, or you can say omega t plus or minus ks, where a is the amplitude, omega is the angular speed, k is the wave number. Now, you have the plus or minus. These plus or minus cannot come at the same time. So you have plus or you have minus. The minus there is for a wave which is moving from left to right. Now we represent it with a minus. So assuming we have a plane wave like this, which is moving from left to right, we represent it with negative sign. If the wave, assuming the wave is now moving the other way around from right to left, we now represent it with plus. Now, for the sake of this class, I am going to concentrate on one. Let me use minus. So for an advancing wave which is moving from left to right. Now in this case, we always do is to put out what these things mean. So the angular speed is 2 pi f, or 2 pi all over the period. So where f is the frequency, t is the period. Now k, which is the wave number is expressed as 2 pi all over lambda. Now, if we substitute these values into this, we will now have that the equation of the traveling wave is given as a sine. And in place of this, I can now have 2 pi over period. Remember, this time always attach it minus. In place of k, I can have 2 pi all over lambda. We'll put your x. So I'll label this one as equation 1. Let's say 1a, and this one is 1b, because these two equations are the same. Just like this is an expanded form of this. So since we have this equation as this, this equation can also be written as y is equal to a sine. I want to leave this one like this. If I leave it like this, we can have let's say 2 pi f. You put your t there, minus k. I can have my k as 2 pi all over lambda x. It's still, let's say, 1c. All these are different forms equation 1 can appear. Now, taking this as a case study, we can, because 2 pi is constant there, we can bring that 2 pi out because it's common there. So we have y is, so from equation 1b, we have y is equal to a sine, bring 2 pi outside, we'll now have t all over period minus x all over lambda. I can have here as equation 2, because it has taken into shape now. Now, I can still simplify further. We have y is equal to a sine 2 pi all over lambda is equal to, we have, if we simplify further, we can have lambda t all over period minus x. I can have it as 2a, I can have it as 2b because it's still part of that. Now, recall that V is equal to F lambda from our general wave equation. And also, we can also have that lambda T is equal to V also. So because of this, I can now replace this. If I replace it, we can now have Y is equal to A sine 2 pi all over lambda into Vt minus X. I can call this one equation 3. Please note this equation very well, because very soon we will use this. Now we can still have another equation as we can have this as we can still have Y is equal to A sine. Every equation, there's so many of them, so many of wave equations we can be derived from here. We can also have Y is equal to omega t minus 2 pi x all over lambda. So these are different ways of writing these equations. So, but all you need to do is note each of them, know the particular parameter given. Okay, so we can call this one equation 4. So we can say that equations 1 to 4, 1a to 4 can be used to represent a plane progressive wave. A plane progressive wave. Now, we can take one or two calculations to help us better understand this question. Okay. Now, we have this question on the board. This question came out in WAEC 2020. Now, the question says, a plane progressive wave is given by the equation y is equal to 0.5 sine 1000 pi t minus 100 pi x all over 17. And from here, we're asked to calculate the frequency, the wavelength, and the speed of the wave. So, solution. All we need to do is to relate this equation with any of the equations given. And of course, we'll obtain the equation 4. It is the equation 4 that we can liken this equation with. Of course, this is, so we said relate y is equal to 0.5 sine 1000 pi t minus 100 pi x all over 17. Relate it with the equation that says y is equal to a sine 2 pi f t. Of course, this is this. So 2 pi. Okay, we can relate it with this, please. Relate it with that equation there, which is equation 1c. Okay. Minus 2 pi all over lambda x. Okay. So if we relate it with this, we can have that f is this. Anyone that has t, the trick there is that anyone that has t attached to it is the wave number. So is the angular speed. Whereas anyone that has x attached to it is our wave number. So from what we have here, we can relate it to this. So all we need to do is to equate these two. Equate these two and equate these two. So we have, for the first one, since we're looking for the frequency, we say 2 pi ft is equal to, you relate it with this, 1000 pi t. Make f the subject. If you make f the subject from the equation here, we have that f is equal to 1000 pi t all over 2 pi ft. Okay, sorry. f is no longer there, so we have pi t. Of course, pi can take care of pi t. 2 can come here to give us 500. Therefore, the frequency of the wave is 500 hertz. We're done with that. The second one says calculate the wavelength. And of course, since we're looking for the wavelength, we are still on that same equation. Wavelength is associated with x. So equate this with this. So we now have 100 pi x over 17 is equal to 2 pi x all over lambda. We can cross multiply. If we cross multiply here, we can have that 17, 2 times 17 will give us 34. 34 pi x is equal to 100 pi x lambda. Because we're looking for lambda, lambda is equal to 34 pi x all over 100 pi x. Now, pi x is common, they can take care of themselves. This one can cancel this to give us 0.34 meters as our wavelength. Now for the last one, wave speed. Wave speed is v. Of course, wave v is not given. Wave speed is given as f lambda. Of course, we have it here, f lambda. So we now have that v is equal to f, which is 500 times lambda. Lambda is 0.34. Therefore, the speed of the wave is, by calculation, it will give us 170 meters per second. Alright, this is the end of this. We are going to take the next one. We have the second example here. The wavelength of a traveling wave is 15 meters. Sorry, it's 5 meters at a frequency of 12 hertz. Calculate the wave velocity. And the second question there is, if the amplitude of the wave is 15 meters, write down the equation of the wave. Solution. Now, from what we have the wavelength of a traveling wave. We have that wavelength is 5 meters. And then the frequency is 12 hertz. And we're asked to calculate the velocity of the wave. So, of course, we know that velocity is f lambda. And it will give us f is 12 times lambda, which is 5. 12 times 5 is 60 meters per second, which is the wave velocity. Now, the second question says, given that the amplitude of the wave is 15 meters, write down the equation of the wave. Now, given this, the first one, we are given something like this, and we're asked to reduce it. Now, they want us to give an equation like that. So, what do? We have already from this, we can have our lambda, and we can have our frequency, our velocity. Of course, none of this has, okay, this one has frequency there. So, if we are to use frequency, wavelength is, okay. All we need to do is, since V is given, none of them has V apart from this. None of them has V apart from equation 3. So we can use equation 3. So using equation 3, we have that y is equal to a sine 2 pi all over lambda equals vt minus x. So we substitute into that equation, which will give us y is equal to a is given to be 15 sine 2 pi all over wavelength. The wavelength is given to be 5 into v. V is calculated to be 60. Remember to put the time-dependent variable there, which is t minus x there. So this is our equation. Or we can still reduce this. We can reduce it. Since 5, we have 5 here. Of course, 5 can divide this. So if we have this, we can have that y is equal to 15 sine 2 pi into, if 5 divides this one, then we shall have 60 over 5 here minus x all over 5. So which will give us that y is equal to 15 sine 2 pi into 16 divided by 5 will give us 12t minus x all over 5. So this is our equation connecting this. Now we can still take the last one. Of course, that one is very simple. Okay. Example 3, we have a traveling wave moving from left to right, has an amplitude of 0.15 meters, a frequency of 550 Hz, and a wavelength of 0.01 meters. Determine the equation describing the wave. Just as we did the other in our example 2, we can still have, from here, we have the amplitude given to the 0.15 meter. And of course, this question came out in JAMB 2014, please. So we have, okay, a frequency of 550 Hz. Then the wavelength there is 0.01 meters. We're actually determining the equation describing the wave. No, nothing was given to us. Of course, this question is similar to the former one, example 2. So we can now have, from here, we can calculate V. V is F lambda, which will give us 550 times lambda, 0.01, which will give us, from calculation, it will give us 5.5 meters. Having gotten V, meter per second, please. Having gotten V, we can go ahead to use this equation. Remember, this equation, this minus shows from a wave moving from left to right, which will give us y is a sine 2 pi all over lambda into vt minus x. So we now have y equals a 0.15 times sine 2 pi all over lambda. The lambda there is 0.01, which will give us Vt. V here is 5.5 t minus x. We cannot leave this with this like this. So we can always, of course, we can just deal with this one without having to divide through by this. So we can have y is equal to 0.15 sine 2 pi all over 0.01 will give us 200 pi into 5.5 t minus x. And of course, this is the linear equation. So which this is our equation for the wave, or the equation describing the wave. Alright, please, thank you for being there with me. Please go through this, and then if you have questions, you are free to put it down in the comment section. Please do not fail to share this information with your friend, because information is power. Thank you very much.